The Bayonne Bridge, connecting Bayonne, New Jersey with Staten Island, New York, is the fourth largest steel arch bridge in the world. For 80 years, the Bayonne Bridge has done its job. But now, in the age of a global marketplace, the bridge has become a barrier. The problem is the bridge is too low, so in the near future, new super container ships on the way to Newark Bay won't have enough room to clear it. To find a solution, the Port Authority is working with two internationally renowned engineering consulting firms to provide technical information on what to do to modernize the bridge. The engineering consulting teams have come up with an innovative solution. Raise the roadway of the arch within the structure of the arch, thereby increasing its height above the water by 40%, while at the same time keeping the bridge open to traffic. It's the quickest option to complete and the most cost-effective. It's an engineering marvel. Here's how it would work. This is a view of the approach road on the New Jersey side looking north. The existing bridge has two northbound and two southbound lanes of traffic and a sidewalk on the west side of the bridge. The traffic lanes will be reduced to one northbound and one southbound lane for the construction period. A temporary barrier wall will be erected along the west edge. The existing west traffic barrier and sidewalk will be removed. A new lane will be added along that west edge. Next, the temporary barrier wall will be removed. The north and southbound travel lanes will be moved to the west side of the bridge once new barrier walls are in place. Then the east side of the roadway will be demolished, allowing for construction of the new approach piers. Precast concrete pier segments will be utilized. This allows for construction to take place within the available work area. This process will be repeated for the remaining piers. A rolling gantry will be erected to transport and place precast roadway segments for the new bridge approach. The gantry will lift and put into place pier segments and temporary gantry supports. The gantry is then rolled forward to the next stage and the process is repeated. A balanced cantilever technique will be employed, alternating placement of the precast segments on each side of the pier. Final adjustments are made utilizing strong backs prior to casting the closure pour. This procedure is repeated for every span. The traffic is then moved to the new structure, one lane in each direction, while the construction process is repeated for the southbound side. The new roadway deck will be constructed above the existing roadway. Transfer load beams will be put in place to allow removal of the existing suspender ropes. New deck floor beams will be delivered, lifted, and rotated into place. Then new suspender ropes will be attached from the arch cords to the new floor beam. New temporary suspender ropes will be attached from the new floor beam to the existing floor beam. Transfer load beams will then be removed. New stringers will be delivered, lifted into position, and attached to the new floor beams. The gantry is advanced and the process repeated. When completed, the concrete deck will be cast on top of the steelwork. The existing bridge has a 6-foot walkway, 10-foot travel lanes with no shoulders, and no barrier between oncoming traffic. The proposed bridge will have a 12-foot shared use path to accommodate pedestrians and bicyclists, 12-foot travel lanes with 6-foot 6-inch shoulders, and a concrete median barrier separating northbound and southbound traffic. When completed, the raised Bayonne Bridge will have a vertical clearance of 215 feet above the water. This will allow the new super container ships to safely pass under the bridge, while at the same time providing motorists with a safer way to travel.